Welcome to Real Learning Center. Today we are actually venturing into a journey of energy. Okay, we're going to talk about different kinds of energy. Energy is the word that we have been very familiar with all these days, and today we are going to dig deep and really understand what is the meaning of energy, and also what is the meaning of potential energy, kinetic energy, work, power. So these new words we are going to understand. So let's start with the basic definitions of energy. Okay, let's start with kinetic energy. That is the most easily understandable and known form of energy. So what is kinetic energy? So let's take a look at this gun, and from there let's say we fire a bullet. So when the bullet actually goes, it has a certain velocity, the moving bullet. Okay, and let's say when a car is actually moving, it has a certain velocity. Car has a certain velocity while moving. Okay, anything that has velocity. So not just in a linear velocity. Let's say this bird is flying, and when the bird is flying, it has certain velocity, and that velocity, whichever has velocity, we say that has kinetic energy. For example, even the case of a huge elephant, which may be actually walking towards me, has kinetic energy. So how much big is the kinetic energy of an elephant? Can we even measure the kinetic energy of an elephant? So I don't want to basically stand here in the front of an elephant. Let's just look at the kinetic energy of a bigger object versus the kinetic energy of a smaller object. What is the difference? Will the kinetic energy depend on the mass of the object? So how much is the kinetic energy? Can we measure it? So that is the question. So if we have actually two objects, it's a tennis ball and a basketball. One of them has mass m and another has mass 2m. I mean double the mass. Okay. If we have double the mass and both of them, let's say they move with exactly the same velocity. When they move with exactly the same velocity, with double the mass, okay, so then what would be the difference in their kinetic energy? So the answer to that question is, if mass doubles, then the kinetic energy also doubles. So we are actually trying to define this energy, the energy which is there in the form of motion. If you have a bigger mass, it definitely has more energy. So we know that. So and we are defining it. If mass doubles, kinetic energy doubles. So we will actually mathematically write it as Ke, that is kinetic energy, is proportional to mass. So this symbol is basically proportional. Ke is proportional to mass. So what happens if the mass doesn't double, whereas the velocity doubles? So you see there are two balls, one of them is v, another one of them is 2v. Okay, double the velocity. So if such is the case, what happens to the kinetic energy? If they move with different velocity, one is v, another is 2v. So what would happen to their kinetic energy? So here we are defining kinetic energy a little differently. We don't say kinetic energy doubles. We say kinetic energy actually quadruples when you double the velocity. You may ask why. Now we are defining the kinetic energy. Why do we do it that way? We will see it later. Okay. So we will find out why we had to do it like that. But as per our definition, velocity actually, when it doubles, kinetic energy quadruples. So we can write it as, when it triples, it becomes 9 times. Now we can write it as kinetic energy is proportional to v square. So to club these two, one is kinetic energy proportional to m, another one is kinetic energy proportional to v square. We can club these two and write a single equation saying that kinetic energy is proportional to mv square. Okay. So kinetic energy proportional to mv square is something that we have come up with. Okay. Now when proportionality constant can be removed by actually putting an equal to with a constant, so we will say kinetic energy is equal to half mv square. Half as a number, constant that we are going to add because of the units that we have chosen for mass and velocity. Okay, so half mv square, and it is measured in a unit called joules. So joules is the unit of energy. So this is what is kinetic energy. Kinetic energy in a nutshell is an energy which is basically possessed when an object is moving, okay, with certain velocity, and it doubles when the mass doubles, and it becomes 4 times when the velocity doubles. Okay, so such a thing is kinetic energy, which is given by the formula half mv square. We're going to use this quite often, okay, and later when we relate it to other things, we'll get a better clarity of why that is half mv square. So now that is about kinetic energy. Now let's talk about potential energy. So potential energy means what? Some potential. So I am having here a magnet, and I am holding an iron screw in my hand. Okay. Suppose now if I release that iron screw from my hand, what will happen? You can see. So release the iron screw from my hand. If I do that, the screw actually gets attracted towards the magnet, and it comes and comes and gets attached to the magnet. Why? Because it was actually pulled by the force, magnetic force of the magnet. If there was no magnet, it would not have come. So when you are holding it in, when I am holding it in my hand, okay, I am actually holding it against the pull of the magnetic force. So if you keep a certain object which is pulled by the force around it, so we call it as a force field. There is a magnetic field around this magnet. We call that as a magnetic force field. If there is an object in the magnetic, in a force field, any kind of force field, if an object is there in a force field, it is considered to be possessing what we call potential energy. It has a potential. What kind of potential? Why do we? Because it has a potential to change the velocity of the object. It has the potential to either decrease or increase the velocity of the object. In this case, it is increased the velocity of the object. It was stationary and started moving. So it has a potential to change the velocity. To change the velocity actually means also to change the kinetic energy, because velocity is basically put into the kinetic energy formula. You see, kinetic energy is equal to half mv square. If velocity changes, kinetic energy changes. That means potential energy has the ability to change the kinetic energy. Interesting, isn't it? So we call this potential energy. But remember that you cannot actually have. See, the potential energy is there when I'm holding it, and it is there when it is traveling. Even while it is moving, the potential energy is there. But the moment it comes and gets attached to the magnet, it loses all its potential energy, because now it can't move anymore. It doesn't have any energy. Okay, so there is a different view. So it's another view of looking at Newton's laws actually. If you see, there are two views. Okay, you are holding the iron in the force field, okay, magnetic force field. Then there are two views are possible. One, you can say that the force field is actually pushing the object. The object is, in my case, a iron screw. The force field is pushing the object, is one way of looking at it. There is another way of looking at it. We can say also that the object actually has potential energy, which makes it accelerate in the force field. Means that there is a field. When an object goes into that field, it will possess certain energy, which will make it accelerate in that force field. So what do you ascribe that to? Do you ascribe that to the force field or to the object itself? Okay, so that is basically those are the two views of how you look at Newton's second law. It is ultimately Newton's second law. There is force and there is an object, and force is exerted on the object, and the object moves with an acceleration. F is equal to ma. So that can be viewed as also a possessing a potential energy. Okay. Now, with that, so what we can say is that when you talk about force field, it is not always that it is a field which is which you can't see. It is also about some contact forces. Here ultimately can be boiled down to certain force field here, but you can see the spring. when the spring is pulled, okay, at that time it has a tendency to come back. So that means that when it is stretched, we can say that it possesses potential energy. Okay, so when it is not stretched, it is not having any potential energy. So that is the various views of understanding potential energy. Now, if you actually look at potential energy due to gravitational force, it is if there is a force, wherever there is a force, there is a potential energy that is possible. The force field is there, gravitational force field. Now, let's say this is our earth, and I am standing here with a ball. So the ball, when you drop, it goes towards the center of the earth because of the gravitational pull. Okay, and the mass is, let us say, m, and the height is h. So what happens when you drop the ball? When you drop the ball, it moves towards the center of the earth. Okay, so basically that is what it is exactly similar. That when I release my iron screw, it went towards the magnet. Similarly, here when I release the ball, it went towards the earth's center due to gravitational force. So this gravitational force, in that case also, is responsible for the potential energy possessed by the ball. Okay. So we will say that gravitational force between ball and earth, if you see, actually will accelerate the ball with acceleration g is equal to capital F by m. F is the gravitational force between them. M is the mass of the ball. So that is how it actually accelerates. And that is always acting on it. Such a force is actually acting on the ball, even when it is standing. Okay. So at that height, if you have such a gravitational force acting on it with a g as acceleration, we will actually define the potential energy. Now, the potential energy, the way we define is, it is higher when you go farther from the earth. Okay, that means when you go to a higher height, the potential energy is higher. And also, it is higher when the mass is higher. If you have a bigger mass, higher potential, it has more potential energy. Because a bigger mass dropped onto us will cause more harm. Okay, so it has more energy. So we can say in summary, we will say potential energy is given by a formula called as PE is equal to mg into h, which means mg mass into acceleration due to gravity, basically together is called force. Okay, this is a force which is basically getting pulled, m into g. Okay, F is equal to ma. That is the force. We even call that weight, mg as weight. Weight is a force. Okay, into the height. That gives us the potential energy. So here we are making some assumption. The assumption is the value of g is actually not changing when it is moving here near the earth. The acceleration due to gravity, but in reality it changes a little bit, but we will take it as constant. Okay, so P is equal to mgh, joules again, we measure it in joules. This is the potential energy due to gravitational force. Whenever you talk about potential energy, you have to always talk about due to which force. If there is no force field, there is no potential energy. Remember this. Okay, if you want to keep a certain ball in the space where there is no force anywhere, force field, then it doesn't possess any potential energy. Leave it here, it stays there. Okay. So now let's go and understand whether the potential energy is a relative or an absolute measure. Okay, potential energy is actually a relative measure. If you look at, let's say you look at this scenario of a house here, and the boy standing on the top of the house, and a lady standing in the middle tier, mezzanine floor, and the man standing on the slightly lower height. Yeah, all of them are actually trying to measure the potential energy of this ball. So they want to measure the potential energy. The ball is there at that height. It's being held through some rope or something like that. It's standing there, or it may be falling, and it is at that instant. It is at that height. Okay. So now the boy says that the ball is at the height of 3 meters, and the lady says the ball is at the height of 4 meters. For her, she measured with respect to her floor, okay, wherever she is standing, and that is 4 meters. And the man says that no, it is 5 meters. He has measured it from his level, where he is standing. Now with that, what is happening is that all of them are going to compute the potential energy based on them. All of them know the formula. Okay, and they know that the mass of the ball is 0.5 kg and acceleration due to gravity is, let's say, g is 10 meter per second square. So you need these two values to compute potential energy, because formula is PE is equal to mgh. So this boy substitutes the value of h into this formula, and he says 0.5 into 10 is 5, into 3 is 15, so I got 15 joules. So he says potential energy of the ball is 15 joules. And the lady says, no, you're right, G is 10 and mass is 0.5, multiply with that is 5 into 4 is 20 joules for me. And the man says, no, it is 25 joules for me. So like that, all the three of them have computed the potential energy as three different values. Now when potential energy has these three different values, which one is right? Actually, all the three are right, because potential energy is a relative term. Okay, potential energy, when we talk about with respect to certain height or certain distance, we always take a certain base, from there we measure. So potential energy itself we don't generally use. We use the difference in potential energy, in the sense that suppose if you take another ball which is around 1 meter below the first ball. So if it is 1 meter below from here, then you may ask a question, what is the potential energy of that? Potential energy of that is, you can calculate again. In the first case, potential energy of that is about 10 joules. So now the difference 15 minus 10 is 5 joules. The boy got 5 joules as the difference in potential energy. And the girl, the lady again, calculates again. For her it is 3 meters now. She gets 15. So the second ball is 15 and the first ball is 20. She says 20 minus 15 is 5. Similarly, the man again computes and says it is 5. So all of them are saying the difference in the potential energy between the two balls is exactly 5. So difference in potential energy is absolute, though potential energy itself is a relative term. So please understand this. Difference in potential energy is absolute, whereas potential energy is relative with respect to the height from where you measure. Okay, this is true in almost all the cases. Okay. Now, what about kinetic energy? Is that relative or absolute? So let's see kinetic energy. Kinetic energy is also relative. So here is a boy standing on a trolley and a man standing on the road. Both of them are watching something. Okay, and the boy on the trolley is moving with certain velocity. Okay, and the man on the road is standstill. So they both measure the velocity of this elephant which starts walking. The boy measures the velocity of the elephant as 3 meters per second, and the man measures the velocity of the elephant as 5 meters per second. Now both of them have measured the velocity, and both of them actually know what is the formula. So they know mass of the elephant is 1000 kg, and the formula for calculating the kinetic energy is half mv square. The boy actually calculates it, and he says that half into m is 1000, half into 1000 into v square. V is 3, v square is 9. So 9 into 1000 is 9000 into half is 4500 joules. Similarly, man computes it to be 12,500 joules. Man says the kinetic energy of the elephant is 12,500 joules. The boy says it is 4,500 joules. Which is right? In fact, both of them are right. Assume it is again it is relative with respect to your own velocity. Okay. If you have actually taken, let us say, another vehicle is moving there by the side of the elephant at a different velocity. Now both of them measure that velocity, and both of them will compute the velocity of the car and also compute the kinetic energy of the car. Now they will say, boy says, that difference in kinetic energy between the car and the elephant is this much, and difference in kinetic energy of the car and the elephant is this much is also man says, and both of them this time will be saying the exact number. That is why the difference in kinetic energy is absolute, whereas the kinetic energy value itself is relative with respect to your own velocity. Okay. So now we understood that both of these things, kinetic energy and potential energy, their differences are very important. Their actual value itself is relative with respect to what your velocity or your position is. Okay. So now there is also another aspect between potential energy and kinetic energy. They are actually interconvertible. So what does it mean? I can convert potential energy into kinetic energy and vice versa. How do we do that? So let's drop the ball towards the earth. So while it is coming down, we know that the height will be decreasing and velocity will be increasing. But once it pitches and goes up, height will be at that time increasing and velocity will be decreasing. So height and velocity are the two important parameters to determine potential energy and kinetic energy. Let us see what will happen to the potential energy and kinetic energy when it is falling down or when it is going up. When it is falling down, you can very clearly see the height is decreasing and hence potential energy is decreasing. Velocity is increasing and hence kinetic energy is increasing. The moment it pitches and starts going up, height is increasing, so potential energy is increasing. Velocity is decreasing, so kinetic energy is decreasing. So what is happening is, while it is coming down, okay, we can say that PE is getting converted to KE, potential energy is getting converted to kinetic energy. Whereas while it is going up, what is happening? Potential energy is actually increasing. That means kinetic energy is getting converted to potential energy. So there is kind of a interconvertibility between potential energy and kinetic energy is possible. It happens. It keeps happening in the nature all the time. And if you see actually this addition of the potential energy and kinetic energy, we call mechanical energy, and that remains same. It's constant throughout. If you actually see that when the ball actually is coming down, we can see that the loss in potential energy will be exactly equal to the gain in kinetic energy. How much it loses in the potential energy, it gains in the kinetic energy. When it is going up, loss in kinetic energy will be equal to the gain in potential energy. So, what really happens is all the time the total mechanical energy remains constant. That means potential energy plus kinetic energy, if you add them, that value remains constant. So that particular principle where mechanical energy, that is sum of potential and kinetic energy remain constant. Now that is called as law of conservation of energy. That means energy does not change. Total energy remains constant in a given system. The total energy remains constant. So that is called law of conservation of energy. That's a very interesting law. We are going to use that law going forward many times. Okay. So in the whole of this video, we actually learned what is the meaning of potential energy and kinetic energy, and we also learned how to compute them in some places, and we also learned basically how to convert them from one to the other, and finally we understood the law of conservation of energy. So watch the next video. We are going to talk about work and power, which are another avatar of potential energy and kinetic energy. We'll discuss about that in the next video. Thank you.